Okay, question was just asked about nozzle sizing for a Norstar head, and we've got several different sheets here that are showing different patterns. This particular sheet has a pattern for the long shot setup, and then down here is a pattern for not the long shot setup. Now this one is a 25 gallon per acre at 11 mile per hour pattern. And up here we have an 18 gallon per acre at 15 miles an hour, or 25 gallons per acre at 11 miles per hour, so on and so forth. I'm going to just explain what all this means. You really don't need this sheet at all to figure out what nozzles you need in the truck. You just need to have a working understanding of what we're trying to accomplish. So what I'm going to do is I'm going to talk about what we're trying to accomplish first. So with this particular pattern setup, it's telling me Norstar wide setup for Iowa, speed is 5 to 6 miles per hour, 50 gallons per acre. Okay, that's not what we're looking for. All right, we're looking to create a setup for 35 gallons per acre at 10 miles per hour. That would be our typical PennDOT setup. So if I just flip this over here and I talk about a PennDOT setup is going to be a 2 foot, 2 foot, 4 foot, 4 foot, 4 foot, 6 foot, 6 foot, 6 foot pattern. Okay, so if this is my truck with my Norstar head, I'm an artist, so you'll see that, and I have a 2 foot, a 2 foot, then a 4 foot, a 4 foot, and a 4 foot, then a 6 foot, 6 foot, 1, 2, 3, 4, 5, 6, 7, and 6 foot. So we've got 6 and 6 is 12, 18, 22, 26, 34 foot total, right? So there is a 34 foot pattern. Did I do that right? 2 and 2 is 4, 8, 16, 20, 32. No, what did I just screw up? 20. 4 and 4 is 8, 12, 16, 22,
28,
28, 34. Okay, yeah. So that's 34 feet total. All right. And our booms need to deliver the correct amount of material at each site. So what I'm going to do is I'm going to go to a website here called Ag Spray Parts. Actually, tip calculator. Okay, so Ag Spray Parts tip calculator right here. This website right here is my favorite. And and what this does is when I scroll down here, it says that if I want to spray at 35 gallons per acre and I want to travel 10 miles per hour, okay, and my nozzle spacing, and here it says nozzle spacing in inches, right? So what I would need to do is I would need to take 34 feet, 34 times 12 is 408 inches. So if I put in here 408 inches and then I hit calculate, it's going to tell me that this entire Norstar head, when everything is turned on, should put out 24.04 gallons per minute. All right. So that 24.04 doesn't really have any big significance to us, but it'll help you understand what we're trying to figure out. So all of these nozzles together should add up to a flow of 24 gallons per minute. So if I back up and I take my 408 inch spacing out and I put in 24 inches of spacing, okay, what that is that's for boom 1. So boom 1, 2, 3, 4, 5, 6, 7, 8. Okay. So boom 1 needs to deliver 1.4 gallons per minute. And usually boom 1 will have 4 tips in it. So right here, it's showing me boom 1. In this particular case, boom 1 is using an S1/8 U. And what that stands for is S stands for straight tip. 1/8 is the thread size of it. U is the type of nozzle it is. So it's an 1/8 inch straight tip nozzle dash 0004. And the 0004 means that nozzle is capable of putting out, when sprayed at 40 psi, 0.4 gallons per minute. So if I were to have 4 nozzles spraying at 0.4 gallons per minute, let me go back to my calculator. 0.4 times 4 equals 1.6 gallons per minute, and I am looking for 1.4 gallons per minute. So that's pretty darn close. So technically, if I were to say I want 1.4 gallons per minute divided by 4 nozzles, I would technically need an 1/8, an S1/8 U dash 00035. They don't make such a nozzle. They do not make them in that would be considered a half size between these. So your choices are going to be a 0.4 gallons per minute, a 0.5 gallons per minute, a 0.6 gallons per minute, a 0.7 gallons per minute, and so on. So what I could do is I could technically put a plug in one of the holes, and I could say 1.4 gallons per minute divided by 3, and then I would need a 0.46. I would need 3.46 nozzles, or that would be closer to a 0.5 nozzle. So in that case, down here, I could use 3 8th U dash 0005s, or I could use 4 S8th U dash 0004s. That's as close as I'm going to be able to get. Or the other thing I could do, let's see, the 4, well, yeah, because they're all too big, right? So what I'm going to say is that my boom 1 is going to be 4 times 0004. And that's going to be slightly larger than what I want. I only want 1.4 gallons per minute. That's going to give me 1.6 gallons per minute. It's as close as I can get because that's the smallest nozzles that are available for us. So the next boom is going to be the exact same thing because it's the exact same width. However, what you'll see here is on boom 2, they put a plug in one of the holes, so they reduce it to only 3 nozzles, so they go to a larger size. There's really no reason for that other than instead of having 4 streams coming out and hitting the ground, they only have 3 streams coming out and hitting the ground. So I could use 4 0004s, or I could use 3 0005s. It's interchangeable. Either one is not the exact right number, but it's very close to the right number. Okay. Now let's go to our next boom. It's going to be a 4-foot boom for number 3. So if I change this to 48 inches and calculate, I need 2.83 gallons per minute to come out of that boom. So let me move this over here. So 2.83 divided by 4 nozzles, okay, would be a 0.707. Well, we have 0.7, so that would work. And when I look at this, it says boom 3 gets quantity of 4 0007s. So that makes it correct. 4 times 0007 will deliver me 35 gallons an acre at 10 miles an hour. Okay. Watch what happens if I change it to 5 miles an hour, though. If I go to 5 miles per hour, I only need 1.4 gallons per minute. So at 5 miles an hour at 35 gallons an acre, I would need a significantly smaller set of nozzles, right? I would actually, at 1.4 divided by 3, or we'll do it by 4 actually. So 1.4 divided by 4, I would need my 3.5s again, even in that wide pattern, if I was going to drive 5 miles an hour and put out 35 gallons an acre. So everything is reliant on something else. When we set up the trucks in Iowa, we have to drive at 5 miles an hour because we're putting out 50 gallons an acre. When we did the Ohio Turnpike, we were trying to put out 60 gallons an acre, so we had to have really big nozzles for that. And every application is a little bit different, but the bottom line is that you're always going to use the same formulas to figure this out. So now, boom number 3, 4, and 5 are all 4 foot wide, so they're all going to be 48 inches. So you could say that booms 3, 4, and 5 all get the same nozzles. They all get 0007s if we're driving 10 miles an hour and putting out 35 gallons an acre. But when I look at this, boom 3 has 0007s, boom 4 has 0010s. Why is that? Here's why. Because they put a plug in one of the holes and they only ran 3 nozzles instead of 4 nozzles. So if I take my 2.83, so 2.83 divided by 3, I come up to 0.94. Okay, so you could run 3.9 nozzles or 3.10 nozzles, right? It's more than 9, it's less than 10. What if we were to put 2 9s and 2 10s? All right, well, that'd be too much. What if we put 1 9 and 2 10s in there? That would be acceptable. 2 10s and 1 9 would be acceptable. All 9s would be acceptable. All 10s would be acceptable. Or you could take the plug out and return it to a 4 boom or a 4 tip nozzle setup and use all 0007s, right? So here I'm just going to say 4, I'll say 3 times 0010, okay? And boom 5 now, same thing. Now in this case, boom 5 on this chart goes back to 0007s. I don't know what the significance of that is. What they're trying to maybe imply here, the engineers that drew this, is maybe at that distance from the truck, they think that 3 nozzles is sufficient to put the material where it needs to be. 4 nozzles, 6 one, half dozen the other. It doesn't really matter. You could take that plug out and put in 0007s in all of those center booms. So we could use 0004s in booms 1 and 2 if they both had 4 tips. And then we could use 0007s in 3, 4, and 5 if they're all the same width. And then you can see here that we could really use the same tips in 6, 7, and 8, although we don't, and I'll show you why as we build that out. So let's go back to 6 foot times 12 inches wide is 72 inches. So if I go to a 72-inch pattern spacing, I need 4.24 gallons per minute coming out of that. All right, well, 4.24 divided by 4 equals 1 gallon per minute, right? So I'm back to the same thing here, that booms 6 and 7 being 6 foot wide should get 00010s, 4 of them. What if I only had 3 nozzles in one of those, right? So 4.24 divided by 3 would be 1.4 gallons per minute. So those would be 1 4 nozzles, 014 0 nozzles, which I believe we have some of those. I believe they exist. 0014, I'm sorry. Not 014. 0014 would be what would go in that. 3 of them. Or 4 0010s. The bottom line is we're trying to get up to 4 gallons a minute. So a gallon a minute per nozzle times 4, or 1.4 gallons per minute per nozzle times 3, either one would work. So 0010s 4 times, or 3 times 0014. Okay? And then finally, boom 8, because of the distance that boom 8 travels, it needs the same 4.2 gallons per minute, but we want it to be a fairly large nozzle because it has to have a lot of distance. So what we do in that case is we just divide it by 2 nozzles. We only put 2 tips in the very end. And when you put 2 tips in the end, you need a 2 gallon a minute tip, which is a 0020. Now, a lot of times they'll put a 0030 in with it. And the purpose of that is to just send a little bit more volume to get that last tip to travel just a little bit further. But by the math would only require 2 0020 nozzles in boom 8. And the reason we're doing that is because we want it to be a big fat stream that has a lot of weight to it, so it'll travel a long distance. So when we're talking about spare tips or what tips go in what set, if all else fails, if you don't have a handy chart to tell you, you can always just figure out what you're trying to put out on that boom and select the nozzles that are appropriate. And remember, these are not an exact science. There's always more than one option and more than one tip size that you can make a combination to achieve what you're trying to achieve. So here endeth the lesson.